This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Threat modeling for DevOps? Yes, you can. Yes, you should. Please give a warm welcome to Adrian Sroka. Hello.
Okay, hello. As you already heard here, I'm Adrian Sroka, and today I want to tell you why threat modeling is important also for the DevOps, not only as you could think for the developers in the development team. So let's start. So generally, how we usually create software. Usually we start with some kind of idea, then you probably recognize it. This is the DevOps cycle, classic representation of the way how we produce software. At first, we need to have idea what we want to have create. Then we need to some resources, planning, how to do this, code development, build, test, and so on and so on. If it is tested, if it works as designed, as sponsors or the business want, then we could release it to the production, deploy it, and so on. But when in this process, what do you think? When in this process, we should start thinking about the security, or where do you, usually we should handle the security in this whole DevOps cycle? Yeah, that's right. The sooner the better, but generally not only the sooner, not only during the plan, but the security is important at each step, at each stage of this development process, at each stage of the SDLC in the development area. Because at first we need to think about the security during the planning, during designing some feature, some system. Because, for example, if some business want to create a feature functionality that enable to log in using the PESEL number or some random ID with not very high complexity, it should be blocked at the beginning, because as soon as we identify some problems, especially security problems, if we identify the security problems sooner in this development process, it will be much cheaper to handle it, because we could imagine that that kind of functionality will be much easier and cheaper to handle at the beginning of the process than comparing to the production when, for example, somebody try to use this functionality in the wrong way, in the bad way, as an attacker, as a hacker. So the next question: where do security problems arise in this development process? We could think that usually the development problems, the security problems arise during the development in this DevOps cycle, because development is usually the most complex one in this whole SDLC. But is it true? Not only, because not only developers is part of this whole ecosystems. The artifacts created by developers, the systems, need to be run in some environment. And this environment also could be problematic from the security perspective. Moreover, the way how we create the software also could be problematic, not only the logic inside the application. So let's think, what will happen if, for example, we would have a situation that we have a company, we have a system. The system is distributed to multiple dozen of different customers, and at the central place in this company, we have some kind of update platform to propagate the updates to each instance on the customers. And some attacker get the access to this update server and try to, not try, but in fact, inject some malicious script, malicious functionality code into this platform update using some plugin or something like this. What will happen? It will result that all our customers will be infected using this one single point of updates. generally usually used for good because usually it's used to make sure that each customer is up to date according to our standards. Even from the security reason, it's very important. But when some malicious actor, some attacker get access to this update platform, then it will compromise all our customers. And it's not very imaginated scenario, because that's exactly how the attack in SolarWinds happened in some time ago, a few years ago. Okay, the next example, what will happen if, for example, some employee in our company, for example, some administrator in the company, open a phishing email. For example, a phishing email which gives some reward for clicking something or redeeming something on the internet. As a result of this phishing email, the employee will show the login panel to some system, then try to log into the system. But as a result of these actions, the credential to some tool used in the company will leak to the attacker. For example, this tool could be some administrative tool, and it could result in, for example, some data leak. For example, if this administrative tool would be an administrator panel for e-commerce systems, then it could leak the data of all our customers in our platform. And this, as you could guess, is also the real life attack aimed to the target company. And as a result of this attack, about more than several millions or even a bigger number of personal data of customers of this shop leaked on the internet using this simple scenario. So generally, as we could see from these two scenarios, attack not only target the system, the logic on the system. It could also target some environment, how the system are built using for example, repository, some deployment server or something like this, but also could target some other places in the application, like logs or some administrative tools which we use to administer not only the application itself, but also the platform, for example, to administer the databases. That's why it's not only the responsibility of the developers to think about the security. Also, it's very important that other people related who have impact on the final product, on the final system, think about the security as well. Because it's important, because generally security is not easy. Security is quite hard to measure, because the good security is a situation when, for example, any attack don't happen in our system. It's not usually it's not very easy to measure that there is a try to attack, but it's not happen, because some of attacks could be stopped or at a different level of the environment. So it's not very obvious how to do this. Also, the security is hard to imagine. The problems in the security is real, but usually the way how the attacker works in our system and the way how attacker try to misuse our system, abuse our system to do some wrong stuff in it, is very, very creative, and it's very hard to imagine, hard to predict what attacker could do right now in the system to, for example, steal the data from this. That's why it's not very intuitive, because it's hard to predict. Also, very problematic and very not usually not known fact is that security, especially the development security, is not very well known from the people, because usually on the academics, on the different courses, on different schools, is not the main focus. Usually most of the people on the schools teach about the performance. It's very important. It's very easy to measure. People try to code the very optimal algorithm. People try to measure what is the performance of the system, and so on and so on. And there's plenty of tools to do this, but there's not as usual to measure and to think about the security. That's why it's not easy, the whole security topic. That's why it's very important to have a DevOps to think about the security, because DevOps could increase the security level of the whole ecosystem of the system, or whole ecosystem in two different ways. At first, by securing their own backyard. What does it mean? Securing their own backyard, it means thinking about their DevOps tools. As a DevOps, usually you use some tools to handle the repository, to build some artifacts, as a continuous integration, as a deployment server, for example, some tools to Nugget feed, to Docker feed, or something like this. And we have plenty of tools to automate, to help us with the task to create the system from the code to the production. And as a DevOps, you could try to secure and think about the security of your own backyard, of your own tools, which you usually on everyday basis use to automate your work. But also, very, very important thing is a very important way how to think about the security as a DevOps is to guarding the street. Not only thinking about your own backyard, but also about the neighborhood as well. This neighborhood is the DevOps, developers, because developers create some artifacts, some code in the repository. And you as a DevOps have a power to push this code through the whole pipeline to the production. But on this whole pipeline, you are, for let's say, the last resort, last bastion to check the security of this artifact, because you are the one who push it to the production. So you are also the last one, probably, in the company, which could detect some problems with the code. Even if some problems will get away from in the code from the developers, you are the one who could detect it and try to eliminate it, or at least inform it to some other team members. That's why, in my opinion, DevOps is very crucial for securing systems. But the question is how. So how, in an easy way, we could think about the security as a DevOps. The easiest way, in my opinion, is threat modeling, because using the threat modeling, we could try to identify the potential problems in the system and think what could go wrong with the system, how potential attacker could do something wrong in our configuration. Not only, from your perspective, not only on the application of the system level, but also on the whole ecosystem. What potential attacker could do something bad in, for example, CI/CD pipeline. When you use, for example, Azure DevOps for hosting pipelines, what could go wrong if somebody get access to Azure pipelines? If there is a way to misuse it, to do some attack using this single access. But let's start with this general thinking. What is the threat modeling? Threat modeling is, as I said before, is an activity to identify the potential threats. And threat modeling, in fact, is well known by probably all of you, because it is used on the everyday. For For example, if you drive a car in a snowy road, you could think about the safety of this. If the velocity of the car is proper, if you manage to brake, if somebody will run over your car or something like this, if it is safe, that if the way of driving the car in this weather condition is safe or not. And this is the threat modeling, thinking what could go wrong in the current situation when you, for example, driving a car. But also, you could think about what could go wrong when you deploy the application to the production, or when you run the pipeline, which deploy the application to production as a result. So, generally, all of you already do the threat modeling, and even if you are not aware, you already know that threat modeling is usually used by you. So, what is the biggest benefit of the threat modeling? At first, of course, more obvious one, it's an increasing of the security level, but this is the most obvious. But the very important benefit of the threat modeling is also learning. Because if you do the threat modeling in your development team, in your DevOps team, you share the knowledge. Especially if you work closely with the development team, with the developers, it shares the knowledge about the security problems from your perspective, from the DevOps perspective, not with the developers, which usually think about the application in the wider scope, but by exchanging the knowledge with the DevOps, by working closely on the security topics with the DevOps, each team member could increase their knowledge about the security. And this is very beneficial to change the perspective of the developers and also from the DevOps side, because each one could learn from each other. And also, it's the big benefit about doing the threat modeling is awareness, because when we do the threat modeling more often in the company, when we think about the security more often, then we are in the effect of let's say exposition effect is that's the name. It means that when we are exposed to some factor, for example, to the security topic more often, then it's more obvious for us, it's more natural for us to think about the security problems. At first, because we already know better about the security, but also we are more natural, we are more intuitive about some security problems in the company, in the whole ecosystem. So, let's think about how we can do the threat modeling. We know that taking care about the security is important. We know that threat modeling is easy way how to care about the security, but how to do the threat modeling? Of course, the way how we can do threat modeling, there is a plenty of way. Some time ago, I did the research about it, and I count more than 25 methods to the threat modeling, well-known methods, because every one of you could create your own method. But one of the most popular one, and one of the most which also works very well for the DevOps ecosystem, is Stride. Who knows Stride from the from the audience? Anybody? Okay, so that's better to tell you what is it. So generally, Stride is a acronym. I think it's a correct word, but I don't know exactly. Acronym means it is the first letter from different threat categories: spoofing, tampering, and so on and so on. I will describe it later. But it is 6 categories of threats which we could have in the whole development environment. And that kind of categorization could help us think about the security problems, because instead of thinking about the general security problems, like okay, we have CI/CD tools, some tools, and we could ask the question: what could go wrong from the security perspective in this tool? It's very hard to tell it because it's very too wide to answer it correctly. Instead, we could think about this single category. What could go wrong in this particular tool from the spoofing perspective? So let's start with this description. What is the spoofing? What is the each of the threat category? So the first category is the spoofing, as I already said, is the threat related with pretending to be someone else. So, for example, if somebody guess or get the admin account, admin password for some CI/CD tools in our ecosystem, in our pipeline, then it could go. The attacker, which get the access to this admin account in this continuous integration tool, could do something wrong. For example, could inject some malicious code into the system. And this is the spoofing, the category related with pretending to be someone else. The next category is a tampering. Tampering is a malicious data modification, threat related with some data modification. Not only data, but with some modification of some constraint in our system or data in our systems. So, for example, if somebody, attacker, get access to our code repository and modified something, if in our pipelines there is no additional check like code review or pull request or something like this, which with restriction that some other person need to accept this pull request to be merged to the main branch, that kind of code modification could result in deploying it to the production, for example, automatically using the CI/CD. The next threat category is a repudiation. This is not a very obvious one. It's a threat related with denying of some malicious activity. So, for example, we have a threat that in the continuous integration tools, we don't have any audit trails, any history, who and when and what made in the systems. And for example, attacker do some malicious change in the system. For example, change the URL of some production service, for which service we usually send a lot of data, send, for example, requests for handle the payment or something like this. And we, not having the audit trails in the system will result in the situation that we don't have any evidence, we don't have any proof that somebody in our company, for example, or even, let's say, trusted administrator of our systems, do some malicious activity in the system, and we don't have any method to give some responsibility for this. The next threat category is more obvious one, probably known by all of you, is information disclosure. This is the obvious threat related with the gaining the access to data, to not authorized data, having access to data which I don't have, shouldn't have to. So, for example, if in our repository we have some secrets for the cloud resources, and then if by mistake we publish this repository, this source code to some public resource, like make public in the GitHub or something like this, then some attackers could get these secrets and use it to access our cloud environment, create resources, and so on and so on. And yes. The next category of threats is denial of service. It's also probably known by most of you. Denial of service is a threat related with disrupting the normal system works. It means that somebody from the technical perspective, but also from the functional test perspective, make the system unavailable. For example, in the CI/CD tools environment, somebody could do so many commits to the repository that overload the build server and make it unresponsive. And as a result, it will make not possible to deploy any changes to the production, to do any build in our environment, as an example. And then the next and last one, threat category, is elevation of privilege. It means to having the access to some privileged accounts. For example, if somebody have access by mistake, have access to some privileged accounts to some cloud resources, it could create some resources on our cost, which could be expensive, of course, and also it could have an access to already created instances, data, logic, and can do almost anything. But how this, and this is the 6 threat categories which we could think as a mental model for thinking about the security. It's much easier to think about each threat category separately, but instead of thinking about it globally. So we know how to think about the security, how to help ourselves think about the security better, more precisely, but how to do this, how to apply these threat categories to our environment. At first, we need to model our pipeline. We need to draw somehow how our pipeline looks like in a very easy model. It's something like this. So at first we have a repository, then we have a continuous integration, container registry, and so on and so on. As a final step, we deploy it to some production cloud or something else, and we know how the artifacts are transferred between different systems, and for each element of this system, we could apply the strike category threats and ask the question: what could go wrong from the spoofing perspective on the continuous integration? For the continuous integration, continuous integration system, for example, we could think about the different categories of the threats. So for the spoofing, it could be an example of this potential threat in the continuous integration system. Could be a weak administrative password. For the repudiation, lack of audit logs in the system for any action, and so on and so on. Some other elements in these diagrams, for example, the connection, the transfer between different systems also need to be threat modeled, because during the transfer also could happen some security problems, but not always all type of problems. So, for example, during the transferring the artifacts from continuous integration to our container registry, we could think about the tempering threat, like changing the container registry destination in some tool. What will happen in this way, in this situation, or using the connection with without the HTTPS, so it could be potentially hijacked or modified in some way. So that's the way how we could think about the security, model the whole system, and apply the different security categories from the Stride methodology to the whole pipeline, every element of the pipeline. But this is the first way of thinking about security, keeping secure our own backyard. The second way is, as I said, is guarding the street. Guarding the street, as I said earlier, is about verification of developers' work. Your work as a DevOps here is also very important here, because you creating the pipeline. And in the pipeline, you should think about the different categories of security verification, like static analysis, dynamic analysis, software composition analysis, thinking about what is the security of different components, different dependencies in our systems, also dependencies like libraries, but also external system like software as a service and so on. But also, you could create some automation to verify if in the repository of other configuration we have some secrets embedded. So there's a tools for the secret scanning. But also from the compliance perspective, we should also think about the license scanning. If we are compliant, if we are allowed to use the specific licenses for different libraries in our code. So this is the way how to do this, how to make it easier, because as you will probably think, it's not very easy to start with the threat modeling. From both perspectives, from your backyard, but also from the perspective of guarding, verifying the developer's work. So how to make it easier? At first, the important method how to help yourself with this threat modeling is to share the knowledge about the threats. Learn about the threats, share the knowledge with the other person. Also, by the market threats, like some problems happen in the other companies, but also, very important, about the current and past problems in your own company. To share the knowledge, what go wrong in your company, what was the attack. Usually in the companies, most of the people try to hide that something go wrong during the development, but it is not very educational because if we, of course, if this problem is already solved, if we talk about the problem, if we do some lessons learned from these problems, we are able to think about this problem and predict it in the future in the other areas. Because the experience shows that usually if some problems happen in one area, it is a very big possibility that that kind of problems could also happen in other area of the environment. So that kind of, of course, and the next way how to help ourselves to do the threat modeling correctly is to integrate it in the everyday work, not having it only once a month, a big meeting to think about every threat modeling of everything which we do in the previous month, but to have it in the process. So, for example, before each change, before designing the new pipeline, we should think about the security by one person, by the whole team, DevOps team, or something like this. But having it in the usual everyday process will help to think about the security on the everyday basis, not only on the holidays season. So that's everything from my side. If you are interested in the security topics, you could find me on my weekly newsletter, like Security Champions, on my YouTube channel and on my blog. And that's it. Any questions?
Joining you for the Q&A session. Do we have any questions? Yes, okay, just let me join you.
Hello.
Hello.
Thank you. My question is, like, you talk about security. So is there any automation tool which like take care of it, or is the developers who think and do it manually and find the threat? Like, is there any automated system to find the flaws on the security, or it's the developers and the dev engineers who test it manually and then find it?
Generally, in the developer area, there are many tools which I show you here that could detect in the system some errors, some security problems. But if you detect the security problems, some threats sooner, earlier in this process, it will be cheaper, because using these tools for the development area, you can use this tool only if the code is already prepared by the developer. It means that developer need to design it, need to develop it, need to test it, and something else. and it is pretty expensive to have it all, especially if at the end somebody detects, oh no, it's have plenty of bugs, plenty of security problems, we couldn't push it to production. So it is much more optimal, effective to detect the potential threats earlier in the process and think about the security earlier, but also on the development side, but also from the DevOps perspective, it's not so easy. It's there are some automated tools to detect, for example, some wrong configuration of the cloud resources, but not all tools have that kind of tool, that kind of verification, automatic verification. So many of this security verification, security threat modeling, it need to be made in in our heads still.
Thank you. So I think we can make some automation software for that, I think.
Yeah, because it is pretty custom.
Okay, thank you.
Thank you. Another question.
Thank you very much for your presentation. It was really very, I don't know, so much useful knowledge. I would like to ask you, just because it's pretty expensive to take care about security. So at the moment, I think and have a question to you, how to influence on your team to take care about security on a daily basis?
About who? Who care about security?
Every single team member. Just if I will go tomorrow and tell my guys, okay, let's do that and that and that. They just will tell we don't have time. Like really. So how to, convince my team, my managers that we really need to take these actions?
This is the good point. Your managers, which are already tell, because usually the example need to go from the up, from the managers. Because if the team members tell that I don't have time to think about the security, it's usually the reason is the managers which push the time frame or something like this, the deadlines. And we need to hurry up to fit in this time. But at first, we need to think about the security not as a cost, but as an investment. Because as I said before a few times, if we think about the security earlier in the system, it is much cheaper to handle it. If the security problem will go to the production, then we will have a much bigger problem and much more expensive. So maybe it is worth to think about the security right now during the development, during the configuration of the system, especially when we think about it, when we design this, than letting that some attacker get the data from our system, steal the accounts of our user, and give us, for example, some reputational risk or something like this. This is from the manager perspective, but from the single person perspective, because I also encounter some problems in this area. The way of thinking should be that it's this opportunity to think about the other aspect of the system. If from the from the management level there is allowance to think about the security, many people are happy to think about the security as well, because it is something new. It is something which could increase the level of the quality of the whole system. Because in fact, the security is nothing magic. It's just one of security aspect of the whole project. The same as we think about the performance, the same as we think about the user experience of the system, or some other non-functional aspects of the system, we should also think about the security. And each development team members should think about their work in the very high level, high quality level perspective. And this quality level could be measured also from the security perspective. And giving, usually from my perspective, I will finish. From my perspective, giving the development team members the knowledge, the ability to learn something new, to experiment with something new, will encourage them to explore this topic and to care about this. So generally, my answer to this is to give them space to learn and explore it on their own.
Do we have more questions, or is that all in our Q&A session? Okay, I can see no hands raised. Oh, no, the last one, yeah.
Thank you for your presentation. Question should be short. What about audit, which is provided by companies now? A lot of companies, they prefer to make audit than sharing this knowledge between developers. How do you see this issue?
Yeah, but audit, repeating what I said, audit is at the very end of this process. It is quite of in some cases it works originally, but it's not very effective. Because before this audit, we need to develop it, design it, test it, deploy it to some environment, create all the pipelines and so on. It is pretty lot of work to do before the audit. And having the only one point of thinking about the security, of checking the security guard at the end of the process, it's not very effective because we already built a pretty big car, and just behind the factory door, somebody will tell us, oh no, it doesn't drive, you can't drive this car on the road. You need to start from the scratch. It's pretty hard to change the whole car projects from this stage. It would be much easier to think about it on the earlier stage. But from the other perspective, audit sometimes is required by some compliance reason. So, for example, if your company works with the card data, you need to be compliant with the PCI DSS standard, and part of the PCI DSS standard is a yearly audit. So you still need to have an external audit by the PCI DSS, for example, of course, PCI DSS auditors, but it is only I would say, something like a stamp for the document that it is correct. We need to think about the audits this final verification that everything is correct. But before the audit, we already know it is correct. It is not our single point of verification. Before the audit, we need to make sure that it is correct. And this formal audit is only a compliance way to verify and to have a stamp. Usually, according to my experience, the good way how to connect these two worlds, the security and the development, and other worlds as well, is a security champion initiative. Security champion means that for the development teams, but also for in any other development teams, the security team have some, I would say, representatives, but not representative taken from the security teams and pushed to the, for example, development area, but it is the people from the development area which are with the help of the security team engaged, educated, and engaged in the different security topics, and using that kind of initiative, because the security champion is some kind of internal community of people not working on the security area on every day, but interested somehow in the security, and it is, I would say, some kind of tentacle of the octopus from the security team for different teams, and having that kind of the better name probably is the satellites for the security team in the different teams, which will encourage people to think about the security on your own, and to have an impact about the security, think about the security earlier in the process.
Okay, guys, thank you very much for your questions. And thank you, Adrian, for your answers and your presentation. Now joining you on stage is Pavel, who will give you an award.